Welcome to another lesson with Dr. Hill. What we're going to talk about today is we're going to continue our discussion of voltage, and we're going to look at what happens with the voltage between a series and a parallel circuit. So what we're going to look at is a comparison of the first circuit we built with a single LED and the second circuit that we built with two working LEDs, each connected in parallel. And we're going to try and understand what's happening to the voltage that goes around that circuit. So let's have a look at the board, and we'll transition across to there, and you'll see that I have one circuit already operating. Now what I've done is I've moved the circuit diagrams down here. So this circuit is this circuit up here. If you don't know how this is connected up, go and look at a previous video. This circuit is this circuit here, and what we're going to try and do is measure the voltage across each of the components in the circuit. Now as we add more components, things get a little bit difficult. So for example, here we just had one resistor and one LED, but I'm going to call that R1 and I'm going to call this L1, and then I'm going to write the values down here. And for this circuit, we'll move everything up in a second, but I have R1 and L1 on the first loop, and R2 and L2 on the second loop. Remember, these are connected in parallel. And what we're trying to understand is what's going on with the voltage. Now this can be a little bit tricky to operate everything so that you can see the result on the meter, but let's see if we can do that. I'll get my pen ready for writing notes. So let's get the meter out first, and we'll connect up, we'll test out this first circuit for the resistor. That's 0.91 volts, and let's check the LED. This is a wee bit more tricky. I can connect onto this end of the resistor, and the LED over here, and we get 2.08 equals 2.08 volts. Okay, now what we want to do is we want to go down to our next value, and we'll just do all the measuring in one go. So let's see if we can get this right. Put that there so that you can see it. I'll get my positive end, and we need to connect it up. We need to get some power flowing through. So here's the circuit working, and remember the LEDs look just as bright, but let's see. R1 and RL1 for the first circuit, so this is going to be our positive here and our negative here. .34. So 0.34 is R1. And for R2, let's see, we'll do it this way. Oh, sorry, L1, I'm talking about L1. It's a little bit tricky. Just plug it in there, and we'll connect up here. And, oh, I've got that going the wrong way around. Let's do it the right way around. L1, and we'll take that out there. 2.64. equals 2.64, and then we'll do the same thing over here for the resistor. Let's see if we can get this working. So that's my positive, that's my negative. So we'll go positive, negative, and you'll see that something's happening to the LED here, which is a little bit unexpected. Oh, I know what's happened. I'm connecting up my two crocodile clips down here that are connecting me up. Let's see. Okay, so this resistor is 1.02. And the second LED, we need to get into the positive end, so that's on that end of that resistor, isn't it? So that wire is connected up to the LED, and we'll do this, and you can see that that's 1.96. for LED2. So there are our numbers. We can get rid of this now. We can get rid of the resistor. And let's see what's happening. So in this circuit, if we add 2.08, let's get the calculator out, on, the total voltage is 2.08 plus 0.91 equals 2.99, which is near enough 3 volts. That should be a 3 volt up there, by the way. What have we got here? So in this case, we have 0.34 plus 2.64 equals 2.98 volts. It was very awkward to measure, so we maybe lost a little bit of accuracy with the awkwardness. And over here we have 1.02 plus 1.96 equals 2.98 volts. Okay, so let's just have a think about this. In this particular case, we've used up the voltage and it's shared between the resistor and the LED. Now this is slightly different to what we got before because we haven't got the jumper cables in the way, and they're involved in the differences between these circuits. So, but what it does is the voltage is shared out between the two components, and it makes up the voltage of the battery. Now what's happening here? Well, it turns out that this entire circuit, R1, L1, is taking up 3 volts. And this entire circuit here, R2, L2, is taking up 3 volts. So in each circuit, 3 volts is shared between the components. But each circuit gets a full 3 volts. So the 3 volts are going in here, and the 3 volts are going in here. Then it's shared. So this is the difference between a parallel circuit and a simple series circuit. When we tried to add an LED onto the series circuit just here, we had to share the whole 3 volts out. But when we got connected up in parallel, we get 3 volts into each leg, into each circuit of the each of the 2 circuits that were connected in parallel. Now, this has a number of implications. What does that mean? Well, that means that somehow we're getting full power into each of the LEDs from one battery by using parallel circuits, whereas when we used a single circuit, we had to share the power out, the voltage out between the components. Now, does that mean we're getting some kind of free lunch here? Well, no, because somewhere along the way, all of this has to be accounted for. I'm putting now 6 volts into my parallel circuit in total, and if you think about it that way, and only 3 volts into my single circuit. So what does that mean? Well, what it means is that if I run my parallel circuit, my 2 LEDs, I'm getting equal amount of power into each circuit, and that will mean that I will run my battery down faster. My battery will run out of power twice as fast as it would just lighting one LED on a series circuit. Okay? And even lighting 2 LEDs in a series circuit, it will still run out at the same speed as a single LED in a series circuit, except the voltage is shared between the LEDs. It's a little bit complicated, and we'll look at it in more detail in our next lesson, and then we'll move on to look at what current is all about. So I hope I managed to do all that in 10 minutes, and if I didn't, well, it was a good lesson. See you next time.